I'm Ryan Walker. I work here at the Cryospheric Sciences Lab. I work on computer simulations of the Antarctic and Greenland ice sheets to project how much of the ice is going from land into the ocean, because it's possibly an important contributor to sea level rise under climate change.
My name is Christine Doubt. I'm researching subantarctic lake development, so using numerical models to see how water builds up and depletes underneath the Antarctic ice sheets.
So we went to the new South Korean research station, Jangbogo, at Terra Nova Bay, not too far from the United States McMurdo base. The Korea Polar Research Institute fed and housed us for 5 weeks and provided helicopters and worked with us. I mean, it was something that we absolutely could not have done without them. In this first study, we were looking at how the ocean tides affect the motion, both horizontally and vertically, of the Nansen ice shelf. Examining how the ice shelf responds to tides helps us get at the dynamics of how the ice flows, and we're hoping will help with future computer simulations. In order to get over to the Nansen ice shelf, you fly over extremely dramatic cliffs, very large areas of ice crevassing. So it's quite spectacular on the way over.
There was one particular moment actually when we first arrived at our tiltmeter site. There was no wind at all and there was quite a lot of snow around. And the most poignant thing, I think, was the silence. When the helicopter shut down, nobody was talking. You could not hear a single thing, and that's such an unusual thing to be able to find in the world. No plane noises, no electricity noises, just absolutely nothing. And it was one of the most spectacular places I've ever been.
The Antarctic ice sheet is flowing under its own weight, spreading out from the center of the continent out to the edges, and when it reaches the ocean, it goes afloat as ice shelves. And where you have ice shelves that are in bays where the ice is in contact with the rock walls, this friction acts to hold back the ice flow. So in some sense, these smaller ice shelves are like corks.
So as soon as you remove them, there's nothing there preventing the ice mass from moving quickly down. So if these calve off, if these break off right back to where the ice is resting on land, it can speed up dramatically. And it's a particular worry at the moment that the ice shelves around the Antarctic are going to break up, and then we're going to see an unprecedented speed up in the ice coming out of the centre of the ice sheet.